We head into 11.4 now, which is simplifying rational functions. What I want you to observe are the objectives below. Please know where we're headed. We're going to be responsible for reducing rational functions. And keep in mind, I'm going to define this here in a second, but rational functions are just fractions. We are going to come across more complicated fractions than this, but keep in mind, I mean, when you go down to the basis of this, I would not say that I have 4 over 2 friends, for example, right? People would just look at you funny and say, you mean you have 2 friends? And you would say, yeah, because 4 over 2 is equal to 2. So we're going to be simplifying some expressions that are a little bit more complex than this, but it's still the same idea. You're also, in order to do this process, you're going to have to review the factoring processes that we have had in the past. So vocabulary. Polynomials, a math expression with many terms being added together. So pause if you would like, but these are going to be the examples that I have for you. This could also be, by the way, subtraction. If you had x cubed minus 4x plus 1. Keep in mind subtraction is essentially, it can be turned into addition, but then you would just have to negate the following term. Technically this should be being added or subtracted together. Okay. And also factors, keep in mind what factors are. There multipliers of a number or an expression. So for example, if you had 2 times 2, these are 2 factors that make up 4. They build to be 4. And then we also have rational functions, which are just fractions. What we're going to be having are some more complex fractions than what we dealt with in chapter X that we just got through. We might, for example, have something like this. Okay, so you might have something like this, which is a lot more complex than basically 4 over 2, but it's still a fraction. It's something over something. Alright, we need to review our factoring. That's one of our objectives. And what you're going to see is I'm going to build these pieces up to an overall objective where we're going to be simplifying, but first we need to review how to factor. So factoring quadratics in this kind of form, remember ax squared plus bx plus c is the standard form quadratic. But if we just let a equal 1, I'm just going to put a 1 out here, we have x squared plus bx plus c. If that is the case, what you want to do is achieve the form, you're going to have x plus something times x plus something, that when you FOIL these 2 factors out, what you hope is to get this expression. The best thing to do is an example. So the numbers that we're going to pick to fill in these blanks, I'm going to go ahead and just put this out here. I have to put a number here and a number here. And specifically what we want is a number that multiplies to be this last number, so negative 24, and then when we add those 2 numbers, it's going to equal 2. So I'm going to start by just listing all of our factors of negative 24. Do note that if you multiply 2 numbers, one of these is going to have to be negative and one of these are going to have to be positive because we have a negative number here. And a negative times a positive would get us a negative. So now let's think of the factors. I could have 1 and 24. So for example, I could put 1 here and 24 there because those multiply to be negative 24, but do they add to be 2? And no. So I'm going to have to keep going in here. I'm going to put 2 and 12. I could go ahead and try putting like 12 here and 2 here because we do know negative 12 times positive 2 would get us negative 24, but it doesn't add to be 2. I kind of didn't leave myself very much room here. I'm going to do 3 and 8. Okay, so 3, 8, or 8, 3. How it's happening, it's not working out, so I'm going to have to keep going. What about 4 and 6? Now here's something interesting. What if I put a 4 here and a 6 here? So let's try it. Alright, so does negative 4 times 6 equal negative 24? Yes, it does. When added, does negative 4 plus 6 equal positive 2? And yes, it does. So you can always check to make sure. Remember foiling, we do the fronts. Check to make sure that if you multiplied these 2 factors together, check to see if it does indeed equal this x squared plus 2x minus 24. So here I'm going to take x times x, that's going to be my fronts. That's just going to be x squared, plus my outsides, so the two outside numbers here and here. We have 6 times x, which is just going to be 6x. That was my outsides, plus my insides. Now keep in mind this is negative, so be wary of that. I have negative 4 times x, negative 4x, plus, and then we have negative 4 times 6. Those are my lasts. That's why we call it FOIL. We get negative 24. So here, those can simplify. These are like terms, so we get x squared plus 2x minus 24. And yes, we did find two factors that when multiplied will equal this. For this example, I'm going to be kind of quick with this. Once again, we're going to have those blanks there. We need to come up with two factors. It consists of an x plus something times an x plus something. That's going to get us this when multiplied 14 and when added 9. So there's not so very many factors of 14. There's 1 and 14, for example. There's also going to be 2 and 7. And there I can hope you can see our matching pair. When you do add those, yes indeed, they do equal 9. So it doesn't matter. You could have put 7 here and then 2 over here. It doesn't matter, because when you do FOIL these out, you're going to get, yes, you do get this. So those are going to be the examples of factoring there. All right, review of factoring a polynomial completely. This actually comes from your 10.8 section that we did a unit ago. So we did our unit of chapter X, and right before that we were doing chapter 10. And this is going to be what you could find in 10.8 if you want some more review and example problems. But what it means to factor completely, you're going to want to identify, are there any common terms that I could pull out from each one of these? And with practice, you'll eventually be able to see this better. I can see something that each one of these have in common. I have an x cubed, an x squared, and an x here. They all have an x within each one. If you cannot see that, so identify any common factors. If you cannot see that, then do a factor tree. So I went ahead and did that. It's a little squished. So on each term, I went ahead and broke this down. This would technically be 1 times x cubed, so you would have this 1 over here, but and then this x cubed, that can be broken down into x times x times x. 9 times x squared, I can break 9 times x squared, but then can you break 9 down? Yes, there we have it. Can you break x squared down? Yes, x squared is consisting of x, two x's being multiplied. That's what that degree 2 means, so x times x. 14, I'm going to break it down first with the number and the variable. 14 times x. 14 can be broken down more. You stop with all of these primes. So the thing is, I want to identify any common factors. These are going to turn red. You can see that in each one of my trees I have an x. You're going to pull that off. Okay? You're going to pull that common factor out, and you're going to put that on the outside of this expression first. So if you pull that x out, you literally rip that off that tree, what do you have left in this term? If you took that x off, you have x squared left. If you took that x term off here, well, you have a 3 times a 3 times an x, so I mean we have plus 9x left. All right, think about it. We have x times 9x, yeah, that equals 9x squared. Plus, you have this last term that you also ripped that x off of that tree. What you have left are these two factors, 2 times 7, which is just 14. All right, check your answer by distribution. If you went ahead and distribute this x to everything in parentheses, because this x on the outside wants to mingle with everyone through multiplication, you would get x cubed plus x times 9x, 9x squared, plus x times 14, 14x. So yeah, you did in fact get it. But this is what I want to do because I've begun to factor it. I have this lonely little factor on the outside and I have this thing in the middle. So we checked my answer by distribution. Now finally, can you factor any further? This is the same problem that we just tackled a little bit ago. Okay, this right here is an x squared plus 9x plus 14. This piece right here, this second factor that I have, I can break down by looking at our last number, finding the factors of that, and then those factors that add to be 9. This is the one that we just did in the previous slide. Okay, so this is factored absolutely completely. the goal of this lesson, I just want to throw this out here. If you went ahead and multiplied this by 2 on the top and this by 2 on the bottom, has it stayed the same? Yes. We get an equivalent fraction. It would be 8 over 14, right? So if you do 4 divided by 7 in your calculator, 8 divided by 14 in your calculator, you get the same darn decimal. All right. What if I were to take 4 over 7 and then I would multiply the top and bottom both by, let's say, 10? Okay. So as long as you're doing what you did on the top to the bottom as well with multiplication or division, you've got an equivalent fraction. Okay, so here the other thing is, you can just cancel those out because that technically is 1 and we get 4/7 once again. Okay, here's a little bit trickier of an idea. If I went ahead and multiplied x on top and x on bottom, have I changed it at all? No, because once again, what's x divided by x? X divided by x, they cancel each other off. You just get 1 over 1. So you still have 4/7 there. You could go ahead and multiply the top by x plus 2 and multiply the bottom by x plus 2, keep in mind once again that those factors could reduce each other. X plus 2 over x plus 2 is just equal to 1 over 1. They cancel each other out. What you just get is that 4/7. Your goal of this lesson is to factor the numerator and the denominator of these rational functions completely and then determine if you have any common factors to cancel out. This is your hope. Can I cancel some common factors out? I want to cancel things out. We just went over factoring completely, and this is our goal, to factor it completely and then identify any common factors on top and bottom and cancel them out. Number 10. Can we factor 15 and x all the way? I'm going to factor this completely. Ready? If you need your factor tree, go ahead and do that. I'm going to have 15 times x. This I'm going to have 3 times 5. All right, so on the top I could rewrite this as 3 times 5 times x, right? All over. I'm going to also factor tree this because I want to factor everything completely. So I'm going to do this 3 times 15. This can reduce by 3 and 5. These are all primes, so I'm going to stop at those. I have 3 times 3 times 5. If you have any common factors on top and bottom, this is where you're going to want to cancel them out now. These will cancel each other out. They just equal 1. 1 over 1. 3 over 3. Those will cancel each other out as well. What you have left then is x over 3. Done. Number 22 is a doozy. I'm going to make a huge jump here. This is that one polynomial that we've been dealing with a lot in this presentation. Factor completely. So can you identify any kind of term that's in each, or any factor that's in each one of these terms? Yes, there is an x, and that's when you would have had left x squared plus 9x plus 14. Please do look at my slide on factoring completely if you don't understand where I came from for that. X squared minus 4. Can I factor this guy, this quadratic? And I sure can. And once again, look back in our slideshow if you are confused as to why I would write this as such. Okay, but I can rewrite this because I can think of a number or a pair of numbers that multiply to be 14, 2 and 7, and add to be 9. So this, if you went ahead and FOILed this all out and distributed that x back in, you'd get exactly this, the polynomial that you started with. Alright, what about this guy, x squared minus 4? Keep in mind, what you have is a 0x in this thing and then a minus 4. So what I still want to do, this is one of those special patterns that we tackled in chapter 10, but what you still want to do is notice that what are some factors of 4? Well, 1 and 4. And by the way, I do know 1 is negative and 1 is positive, right? Because a negative times a positive would get me a negative. So 1 and 4, filling those in there, not going to work. But what about 2? And 2? Oh goodness, look at that. Alright, when you take negative 2 times 2, you get the negative 4. When you add negative 2 plus 2, you get your 0b. If you were to FOIL this all out, we would get, look at these like terms. sorry, plus negative 4. Those like terms will cancel each other out. 2x minus 2x is just 0, so we get x squared minus 4. So this bottom right here, you can factor as well into x plus 2 times x minus 2. And what I hope you can see, this was our goal. We factored the top completely. We factored the bottom completely. Now what we can do is identify here is a grouping or a factor, here is a grouping and a factor that are exactly identical. These will cancel each other out to just be 1 over 1. So what you get is on the top x times x plus 7, x times x plus 7, all over x minus 2. Done!